we have
Today we are going to start section 3 of chapter 8, which is working with some trigonometry functions. So we're going to be using sine, cosine, and tangent ratios. Ratios are fractions to be able to determine side lengths and angle measures. So today we're going to work with just the side lengths, and then next week we will work with finding angle measures.
What's a cosine?
So in your interactive notebook, okay, you have that foldable that has sine, cosine, and tangent going down the left side. Okay? And then going down the right side, you see SOH, CAH, TOA. And that's an acronym that was developed to help you remember these trig ratios. Okay? SOHCAHTOA. Okay? So where they came up with those letters come from the trig ratios. So when we are talking about sine, we're looking at that S. Sine is equal to the leg opposite of the angle and the length of the hypotenuse. So SOH. When we talk about cosine of an angle, it's the length of the leg adjacent to the angle over the length of the hypotenuse. So the CAH, and then tangent, T, of an angle is the length of the leg opposite of the angle to the length of the leg adjacent to the angle. Okay. So those are the trig ratios. It's just a fraction. It's just telling you where you get the numbers to make a fraction. Okay, so we're going to look at some examples of how that works. Okay? So, if you open up the sine flap, okay, on the left side, it says to find the sine of angle A and to find the sine of angle B. Okay? So again, sine is opposite over hypotenuse. Okay? And it always is based on the angle. So when I'm looking at angle A, what is the side opposite of angle A? That is the 6. In the denominator, we need the hypotenuse, which is 10. Can that fraction be simplified?
Into 3 over 5.
3 over 5.
Which is also 60%.
Okay. So the sine of angle A is 3/5. Next, they want us to find the sine of angle B. So what side is opposite angle B? 8. The hypotenuse is still 10. That reduces to 4/5.
What if we did something like angle C, where the opposite is the hypotenuse? You won't ever do the right angle.
Neato.
Okay? Because we're actually going to use that then to find angle measures or to find side lengths. Okay? So, right, you will never use the C. Okay? Good question. Okay, we're going to come back to the problems that are on the right-hand side of your book because we can use any of these. So I want to talk about each one before we get to that. Okay, so if we move on to cosine, okay, so cosine was the adjacent over the hypotenuse. So the cosine of A adjacent is 16. Okay, adjacent is right next to. So 16 over the hypotenuse, 20. 4 goes into both of those. So it reduces to 4/5.
Neato.
Cosine of angle B adjacent is 12 over hypotenuse.
Which is equal to 6 over 10 to 3 over 5. By the
So
way, guys,
4 goes in, and we get 3/5. Okay, so cosine of an angle is adjacent over hypotenuse. And then the third one is tangent, which is opposite over adjacent. So I'm looking at A, opposite is 15, adjacent is 20, and that simplifies to 3/4. And then I look at B. So opposite is 20. Adjacent is 15, which simplifies to 4/3.
That's a lot. It's more than 100%.
Okay, so because we see that trig ratio term in front of the angle, okay, we're just setting up this ratio, that fraction, and we simplify it. Now we'll go back and look at the problems on the right-hand side. Okay? So these could use any of those trig ratios. Okay? So now we're going to take it a step further, and we're actually going to find side lengths. Okay? So here in those first problems we did, we knew all 3 sides, so we could set up the ratio. Now we only have one of the 3 sides, and we have an angle measure. Okay? So just like with the first problems, when we had to look at the angle to figure out opposite and adjacent, with this first problem, we're going to focus on that angle B because we know it has a measure of 21. Okay? So this 9 that I know is the hypotenuse. Okay? If I want to find side BC, what is BC in relationship to angle B?
It is what we call a long.
Adjacent.
We need opposite and adjacent for these problems. So it's adjacent. It's touching angle B. So this is the adjacent. Okay, I'm looking for this side, so I'm going to give it a variable. I'm just going to call it X. Okay, so when I look at the 2 pieces I have, okay, adjacent and hypotenuse. So if I have A and H, which of my 3 trig functions will I use? I'm going to use cosine.
I'm confused,
Okay.
but that's it.
Okay, adjacent and hypotenuse. A and H means you have to use
So we're
the
going
cosine.
X divided by 9.
Okay, so cosine of the angle measure, so cosine of 21 equals,
What does cosine represent?
How'd you get 21?
I know how we solve for it, but does it represent something that's just a
Oh.
illustration?
no, it's just a ratio of the adjacent and hypotenuse sides. Okay? Okay, so cosine of 21, which is our angle, equals adjacent X over hypotenuse 9.
Is that as much as we can do?
Okay, so we want to find X. So how do I get that X all by itself? I'm going to multiply by 9 instead of divide. Okay. So now I have X equals 9 times cosine of 21. Okay, so now we're going to use our calculators. So
This makes-
turn your calculator on.
Okay.
Okay. First thing you always want to check when you turn the calculators on, up across the very top in that dark bar, towards the right-hand side, second one in, you need it to say degree, not radians. Does anyone say radians right now?
I don't know.
Up at the top black bar that goes across the
It
top.
says degree.
Okay, everyone needs to say degree. If it ever says radian, you need to let me know so we can change it to degree. Because if it's in radians, you're going to get different answers.
That's not good. Guys, 9 squared is 81. What's 81
Plug them into a
squared?
computer and put around.
You're correct. No, I haven't even started. Oh, that's complicated. Guys, 6,561 divided by 81 is equal to 81 divided by 81 is equal to 1. Minus 0.4 is
Okay.
equal to 6.
All right, so now everybody's calculator. Guys, we need to be quiet, please. Everyone's calculator has degree. Okay? So now we just need to type it in as we see it. So 9 times cosine 21.
Well,
Okay, cosine, 2 rows above the 789, you see your sine cosine tangent.
found it.
Okay?
Or he found
So 9 times cosine 21 equals, okay, you're always going to have, or most often have, a number that goes on, and your directions are going to tell you what to round to. Okay, for today we're going to round to the nearest tenth, one number after the decimal. So x is equal to what? 8.4. Tenth is one number after the decimal. So 8.4 would be the length of this side. Okay. Now they also want us to find side AC. So I'm going to call that one Y. Okay.
We should probably see.
So when we do this, okay, we have several options of which of our functions to know or use, because now we have 3 pieces. Right? It is better, though, not to use this side that you just found. Okay? Because if you made a mistake in finding x and then you use it in y, then y is going to be wrong too. Plus, we've rounded this. This is not exact. Okay? So we want to still use that given piece that we knew. Okay, so this time, y is the opposite of the angle, and we know the hypotenuse. So if we have opposite and hypotenuse, what are we going to use? We're going to use sine. So sine of 21 equals opposite y over hypotenuse 9. Again, we need to get that y by itself, so we need to multiply both sides by 9. Now the y is by itself. So now it's ready for the calculator. Rounded to the nearest tenth. What is y?
3.2. I got a syntax error.
3.2. So try again. We must have hit something wrong. 9 times sine 21.
In the calculation with a sign.
Okay. So 3.2 when we round to the nearest tenth. Okay. So somebody third period had asked if there was a way that you could check your answers. There is not something that you're going to be able to check to get an exact answer because we've rounded. We do have a right triangle. Okay? So if we did Pythagorean theorem, okay, it should be really, really close to C. It might be just off a little bit because of the rounding, but it would be really close to check it that way. Just looking logistically, okay, so we came up with 8.4 and 3.2. Okay? They're both smaller than our hypotenuse. Okay? So that's a good thing. If we would get some big number for one of these sides, then that would be a concern because we know the hypotenuse has to be the longest side. Okay, so you can just do kind of some number sense things that way. So our next triangle, we have angle C that we know to be 37 degrees. So we want to focus in on that angle C. The 13 that they gave us is our hypotenuse. First side we're going to find is AB, okay? And that is our opposite. Okay? So if we've got opposite and hypotenuse, which trig ratio are we going to use? Sine. So sine of the angle 37 equals opposite x over hypotenuse 13. So what am I going to do to get that x by itself? Multiply both sides by 13. And then again, we're ready for the calculator. 13 times sine of 37. Rounded to the nearest tenth, 7.8. Okay. We also need to find side BC, which would be the adjacent. So if we have adjacent and hypotenuse, we're using cosine. Cosine of 37 equals y over 13. So again, we want to get rid of that 13, so multiply by 13 on both sides. And we're ready for the calculator. 13 times cosine of 37. So y equals 10.4, rounded to the nearest tenth. And then our last example. Okay, we know angle C, so again, that's our focus. Okay, this time they didn't give us the hypotenuse. What side did they give us?
Adjacent.
They gave us the adjacent. Okay. First one I want to find is AB, which is the opposite. So if I got opposite and adjacent, which ratio am I going to use? Tangent. So we haven't done this one yet. It works the same way. Tangent of 50 equals opposite x over adjacent 20. So I'm going to multiply both sides by 20. And then it's ready for the calculator. 20 times tangent of 50. So rounded to the nearest tenth. 23.8.
How do you know which one? Because aren't both sides technically adjacent to that hypotenuse?
No, hypotenuse.
We're always looking what it is to angle C. So adjacent to angle C.
Oh, yeah, I was thinking like
Okay.
adjacent to like that hypotenuse.
No, adjacent to the angle.
Oh, yeah.
Okay. So then AC, we're finding the hypotenuse, and we know the adjacent. So which one am I using here? cosine. So cosine of 50 equals opposite. Okay, you need to go in order. What's opposite? I'm sorry, cosine adjacent 20 over y. So if I take a look at that, how is that different from everything else we've done?
Instead of multiplying, you gotta divide.
Okay, our variable that we need to get by itself is down in the bottom. Okay, so this one is going to look a little bit different.
How
Okay.
is it? Well, that's adjacent, not opposite of the x.
Yeah.
Never mind.
Okay. So with this one, when your variable is in the denominator, okay, to get it out of the denominator, okay, just like we did before, we'd multiply both sides by y, and then we still have this cosine of 50 over here, so then we would have to divide by cosine of 50 to get that to go away, to get the y all by itself. Okay? Instead of having to show those two steps, okay, what we're going to do, so you just need to know this, when your variable is in the bottom, instead of having to show those two steps, we're just going to flip those two pieces around, okay, which is using one of the properties of proportions when you can cross multiply. Okay, so what we're going to do is we're going to put the y on the left equals 20 over cosine of 50. Okay, so we flipped the y to the left, put the cosine of 50 down where the y was. Okay, so when we put this one in our calculator, remember our fraction bar divides. So instead of multiplying, we're going to do 20 divided by cosine of 50. And I heard 31.1. Okay. So this last example that we looked at, that's the one that you need to be careful of. So we always need to make sure that we are following those ratios, getting the numbers correct. Okay? Sometimes we just want to always put the variable in the numerator. Need to watch the ratios because occasionally it'll show up in the denominator. So then we can flip-flop so we can get it in the calculator. Okay? So we need to watch that situation carefully. Okay? Otherwise, once we get it set up, calculator's doing that work for us.